All right. Question number 3. So this is a series circuit. All the things of a series circuit. Total resistance, current in it, current in each thing, fill in the table, and then power of a resistor, the total power, and ultimately I'm going to add, how much energy would it be in 60 in a 1 minute. So anyway, um, so we have the circuit here. This is a basic series circuit. Again, series because it's one after the other. There is one path for the electricity to flow. Calculate the equivalent resistance. For series, total resistance is just R1 plus R2 plus R3. They add up. In series, they add up. So that's just going to be 2 plus 3 plus 4, which is going to give me 9 ohms. All right. Total current. Well, this is going to be V equals IR for the whole circuit. So V equals I times R. This is for the whole thing. So the voltage is 18. Remember, total, battery are the kind of the same thing. 18 is equal to the current I'm looking for times the total resistance 9, which we just found. And so I equals 2 amps. All right, calculate the voltage drop in each resistor. So I'm going to jump right to the table. But again, for each one of these things, I'm just going to use V equals I times R. But I need the current. Well, remember, in series, currents are all the same. I total equals I1, which equals I2, which equals I3. So if I know this is 9 and this is 2 amps in that total current, well, that 2 can go all the way across in series. Remember, complex circuits, this doesn't work. You have to analyze the circuit. But if you know it's all series or all parallel, you can apply the rules to the table as a whole. So 2, 2, and 2. And then I can find the voltage drop for each of those by doing V equals IR. 4 times 2 is 8 volts. 3 times 2 is 6 volts. And 2 times 2 is 4 volts. Final check. 4 plus 6 is 10, plus 8 is 18. So I know I've done that right. All right, calculate the total electrical power for the 4 ohm resistor. So that's the 4 ohm resistor. Power is the voltage times the current. And so power is just going to be 8 volts across it, the energy drop, times the rate that it's flowing through there, 2 amps, and that gives me 16 joules per second, or which we call 16 watts of power. All right. Total electrical power for the battery. Well, then we'll just grab the battery right there. And it's the same equation. Power equals voltage times current. So this is going to be 18 volts, still 2 amps flowing out. And that gives me 36 watts of power. All right. And how much energy for 1 minute? All right. We'll add in energy for 1 minute. E for 1 minute. Well, energy is power times time. And so that's just going to be the 36 watts times the 60 seconds gives me 2,160 joules of energy. Now, again, that's not kilowatt hours. We'll do that one in the next one and a later one, but this is energy just for a single thing. All right. Have a good one, and I'll see you in the next one.